All right. Well, we made it to the end. So, not a lot to talk about tonight. First, I'm just going to start a quick announcement about the final exam. It's scheduled to show up in Blackboard at 9 p.m. So if you uh, don't see it give it 9:10, email me. It will be in the general materials section. I just put it right in that first section. Which actually reminds me, a couple of people emailed me, but I think people are finding it now. For whatever reason, the data project link in Blackboard is like way down on the left side. So just look on the menu. It ended up, I don't know, I can't get it to stay up, but it ended up underneath sort of the general CUNY links, and I can't edit those, and I can't get it to show up above next to the other material. So if you can't find the data project where to submit that, it is there. Just keep going down on the left. So to simplify, on the main like general materials where you submitted Lab 0 a long time ago, the final exam will show up. You won't see it until 9 p.m. Eastern. So in about 59 minutes, it should show up. There's going to be two files. One is going to be a PDF of the final exam, which is 4 pages. And then there's also an R Markdown file that's going to be your answer key. Okay, so it'll be available at 9. It's due on the 17th. You can use, it's sort of open book, open materials. The only thing I really ask is just do this work independently. Like, don't consult with fellow students. I really want to get your responses individually. It's broken down into 2 parts. Part 1 is got a couple of about, I think, 6 multiple choice questions and about 3 or 4 short answer questions. And then part 2 has a small data set that you're actually 4 small data sets that you're going to analyze in R. And here, I'm just going to switch over to R Markdown. I'm sorry, R Studio real quick so I can show this. So you're going to download this file called Final Exam Answers. So obviously put your name in here. It's going to by default knit to a PDF, and that would be highly preferable if you can get it to knit to PDF. But if you never got LaTeX working, then that might not work for you. So you can do an HTML file, and then maybe if you can then create a PDF file from like Chrome, that would be ideal. Worst case is just submit the HTML file. But please don't post your answers to RPubs or GitHub or anywhere else. I just don't want that to be on the publicly available. And just to prevent cheating. So here you can see there's 6 multiple choice. So you can just put the letter next to each here. Here are the short answers. And then, so if you're using the R Markdown, these are the data sets. So you can just load them. And then when you knit this, so I'm asking you to calculate mean, median, standard deviation, and you're going to do some regressions. I set up these variables like this, so you can just replace the NA. This data set is small enough that if you so desire, you can do all this by hand, because there's, I think, 11 observations for 2 variables in each data set. Fill those in, and when you knit this, there's this chunk here that you don't need to modify, but when you do knit this will create a nice little table that will greatly simplify my grading. So I can just look at the table to look for the answers. And then there's 2 more sort of more broad questions that you need to answer about the data set. So try to use that R Markdown file, and that'll generate the PDF that you can submit. So that'll be available at 9 o'clock. If there are any sort of general questions, formatting questions, or clarification questions, of course, you can email me or use the Slack channel or Slack to send me a message, and I'll do that. So that's about the final exam. It's designed. I've seen students, I really designed it to fit into a traditional 3-hour block. So if you're spending it hopefully is not, it should take you about the same amount of time that it take you to do a lab, I would say. All right, questions about that? So that'll be available. Oh, so yeah, so when the link shows up to download the, it's going to be an assignment in Blackboard. and so you're going to have the ability to also upload there, and then it's due by the end of the day of the 17th, which is, I think, is Monday. And yeah, that'll be it. All right, so we got, I think, 5 presentations. So we're going to start with Julie Ann. If I can find, here we go.
Hi, everybody. Okay, I apologize in advance if you hear a dog barking. I hope she stays good for us all. I chose to look at Chapter 6, question 27 on public opinion. This is part 3 out of I think, a 3-part question series. So what they're doing is they're looking at poll data in support of public healthcare options. In 2009, there was 70% of Democrats sampled and 42% of independents that support this public opinion. So I inputted this data in to variables, as you can see right here in the inputs, calling it P1 and P2 for independents, P1 being for Democrats, N1 following the same pattern, and N2 as well. We have the standard error calculation, which I also included from the textbook just for reference, in which we evaluate these inputs using the square root to get the standard error calculation. The goal of this question, is to calculate a 95% confidence interval and interpret it. So with the standard error calculation, we also need to do a point estimate calculation. And with it, with the point estimate calculation, I also included from the textbook. And I didn't show up. To construct the confidence interval, we use the point estimate plus the standard error, and that gives us the upper bounds. And then we have the point estimate minus the standard error, which is the lower bounds. And so put these two variables together, and voila, we have the confidence interval, which is 0.30 to, I think it's a negative 0.30 to 0.25, because I did that.
Okay.
Yeah, that came out wrong. Sorry about that.
That's okay.
So I just wanted to include as a reminder in the beginning of this question, they said that we've put this, sorry, I can't see half my screen with the thing. The conditions for inference have been met. So I just wanted to remind us real quick with finals coming up, the conditions for the point estimate, the P1 minus P2, the proportions need to separately follow a normal model, and the two samples need to be independent of each other. So if independents and Democrats being sampled, we would assume that they are independent of one another. The final question for this is, if we picked a random Democrat and a random independent at the time of the poll, is it more likely that the Democrat would support the public option than the independent? And the confidence interval, as you can see, that it's flip-flop, doesn't include 0. So it actually would be more likely that a Democrat would support this public option than the independent. And that is question 6.27.
Great.
Does anybody have any questions for me?
I don't. Thank you very much. So we're going to move
Jason.
on. Yeah, no problem. So you have Jit, is it Jitendra?
It's Jitendra, but Jit for short, that works.
Jit. Okay, that does. Okay. I see you put that in the go to meeting, but I hid your full name from the sign up. Jitendra.
Okay. And I do switch to desktop, right?
I think so, yeah.
Okay. Well, I did click on it.
Okay.
Would you like to share your screen, get started?
Yep.
Click on the open. Oh, okay.
Yeah, so it'll probably ask you to either share your whole screen or an app.
And then I add to Chrome.
Yep.
Okay.
There we go. I can see your screen. Yeah, we could
All
see.
right.
Yeah, so you can just go to your. Yeah, there you go.
Okay. So I chose two questions to present because they are very much related, and there's not much content in either of them. So I thought it'll be a pretty seamless transition from one to the other. It's about possum classification, and it's about two species or subspecies from Australia where they've classed certain possums from Victoria as 1 and others from New South Wales or Queensland as 0. And they've given certain metrics and the distribution of those metrics for those possums, as well as a full logistic regression model, as well as a trimmed version, a reduced model, where they've removed one that had a high p-value. And it's a little hard to read what the questions are and what the answers are, so I'm just going to highlight the answers. Well, I'll highlight the question first. Examine each of these predictors. Are there any outliers that are likely to have very large influence on the regression model? And just looking at these variables, it will be hard to say. You have some outliers in the distribution, but we don't know if they are influential points. If they follow the same trajectory, as I pointed out in the answer, as the regression line, then no. And when we talk about the regression line, we're looking at the log odds. So the linear regression line corresponds to log odds and not the probability itself. So unless they're influential points, we don't think the outliers are going to have a huge influence, but it will be hard to say just by looking at this. And then part B was the summary for the table for the full model indicates that at least one variable should be eliminated. The second table summarizes the reduced model. Explain why the remaining estimates change between the two models. That's this table over here. It's because there is if there's collinearity, two variables will be competing to share the same information. So if you remove one of them, then all that information will be captured in another variable in the remaining variables. So naturally, the p-values are going to change. And then part 2, or rather, question 8.17, looks at this model again and asks us to write out the equation for the model, and this is the equation. Whereas where sex male is basically a binary, it's a Boolean, it's a true or false. And they've asked me identify which variables are positively associated when controlling for others. And so total length, as you can see, is positively associated. Gender may not be of value unless it is important in its interaction. So basically, depending on if this is 1 or 0, these take on, the rest of the variables take on very different meanings. And then part B was you've got metrics for a given individual, an individual observation. And they say, what is the reduced model's computed probability that the possum was from Victoria? How confident are you in the model's accuracy of this probability calculation? So first of all, I calculate the linear equation, and that gives me log odds or the log likelihood. And then to get the probability, I have to exponentiate it. And so it gives me very, very low probability, which means this is most likely not from Victoria. It's from New South Wales. And then the second part of that question was, how confident are you in the accuracy of the probability calculation? Well, we fitted the models on 140 observations, which is really small. Perhaps if you were privy to accuracy, precision recall, we might be able to make a better estimate about the performance of the model, but I'd be skeptical using such a small sample. And that's it.
Great. Thanks very much. Next up is Anthony.
Okay.
All All right, great. Can hear you and see your screen.
Alrighty. Oh, you see the screen?
Yep.
Okay. So I'm going to do question 8.1. It has to do with baby weights in relation to smoking and non-smoking mothers. So the child health and development studies investigate a range of topics. One study considered all pregnancy between 1960 and 1967 among women in the Kaiser Foundation Health Plan in San Francisco Bay Area. Here we study the relationship between smoking and weight of the baby. The variable smoke is coded 1 for the mothers who smoked and 0 if not. The summary table below shows the result of linear regression model for predicting the average birth weight of babies measured in ounces based on the smoking status of the mother. So writing the equation of the regression line, interpret the slope in this context, and calculate the predicted birth weights of babies born to smoking and non-smoking mothers. Is there a statistically significant relationship between the average birth weight and smoking? So the equation was y equals 123.05 plus minus 8.94 times x. The slope predicts birth weights of a child born from a smoking parent will have negative 8.94 ounce difference from the average weight of a non-smoking parent. The non-smoking mom's average weight, is 114.11, and the non-smoking was 123.05. Since the p-value is very low and less than 0.05, there's a significant relationship between the average birth weight and smoking moms. And that's it. Any questions?
Nope, that's great. Thanks. And then I think Jack is going to pick up with 8.3.
Yes, I'll pick up right from there. Show my screen. Okay. Following. So in part 1, we considered variables smoke and parity one at a time in modeling birth weights of babies and exercises 1 and 2. A more realistic approach is modeling infant weights to consider all the possible variables at once. Other variables of interest include length. I'm not going to iterate through all of them. Quite simply, the question was to write the equation in the regression line that included all the variables. I built this function here. Interpret the slopes of gestation and age in this context. So for all things being equal, for each extra day of gestation, the gestation variable contributes about 0.44 ounces to the baby's birth weight, and likewise, all things being equal, for each extra year of age of the birth mother contributes about negative 0.01 ounces to the baby's birth weight. As for the differences, this is most differences between the smoke variable in this function and this function. It's likely because smoking is collinear with some of the other variables in this more comprehensive regression line. Yeah, that's all I have to say.
Great. Thanks very much. And last but not least, Zachary.
Hello.
Okay, I can hear you.
Good afternoon or good morning. Yes.
Evening for me.
Let's hope this works. All right.
Where in the world you are?
Yeah, I'm in China, so it's getting a little bit after 9 a.m. So.
Wow. Okay. Good morning.
Okay. My screen.
Mm-hmm. Yep. Floor is yours.
So basically, I wanted to share this because it's more related to education, and I figured that some of the open intro questions, most of them have been taken. So what I work as the academic principal of an international high school here in China, and it's interesting that I'm able to get like data sets of students' standardized exams. And so for these Chinese students who are applying to American universities, they all have to take the TOEFL and the SAT. And let me just make this a little bit bigger. Okay.
I don't think you can change the font size. It looks like you're in our studio's viewer. It's large enough for me. For other folks, there's a zoom button
Okay.
on the GoToMeeting viewer if they're having a hard time.
Okay. So basically, I have 2 years of data from this senior 3, which is grade 12, and last year's graduating class. I wanted to see if there's a statistically significant difference between their results, especially of the maximum SAT score that they end up getting. And I wanted to see if there was any correlation and if TOEFL could be used as a predictor of SAT score. And further, I wanted to look at the components of the TOEFL score, which are the 4 basic English skills, speaking, writing, reading, listening, and if any one of those components were a better predictor for overall SAT performance. And then also use this analysis to inform my own decision making at the school. And then possibly even using this, the model that I generated as a way of assessing teachers, using the standardized results as, a metric of performance. So basically what I did is I have pretty small sample sizes. In 2000, this year's class has 23 TOEFL takers, and 46 from the year before. And I used the Plier package to basically summarize the data according to, I have 2 Excels or convert them to CSV. I had a much better time with them in CSV format. And I basically merged them and summarized all of the data so that eventually, let me just skip down here. After merging, I had a sample of 22 students in this class and 24 in this class. And for the current, there's a lot of statistics here, but for the current class, the key is that the mean is about 78, and just that the global average last year was 79, I believe. So, very closely in line with that. And the SAT, the maximum SAT mean was 1229 with a max of 1490. And so I compared that to the other class, and I wanted to, first, of course, test if, this could have a least squares model fit to it based on, the distribution of the residuals. And it looked okay for this class, although I did notice that here, the residuals tend to be positive for the higher scores of SAT. And I was trying to think of an explanation for that. Explaining that as heteroscedasticity seems to be apparent with this. And then doing the same thing with the other class, you notice that the average TOEFL score was about an 88, which is quite high, and the SAT was 1362. So I just wanted to see if that difference of mean, could be attributed to just mere luck, or there was something about that. So I skip ahead here, and I do this hypothesis test. I use this formula where the standard error is calculated as the square root of the variance over the sample size, and the sums of those. I use a t-score because actually I didn't show it, but the other data doesn't seem to follow a normal distribution. So I use a t-score, and then I just set the degrees of freedom to 20. I don't know if there's a shortcut for what to do in that case. But I set the bounds so that the 95% confidence interval was here, which led me to reject the null hypothesis that the means of these scores were equivalent, just because this does not fall, 0 does not fall in this range. So I just want to skip ahead here. You know, I did a regression based on which grade they were in, and indeed, you know, the preceding class seemed to have a higher intercept, and although the slope looked about the same. And just to go ahead here, so eventually what I did is I merged all of the data and then tried to construct a multivariate regression model. And I did some backward elimination so that the model that has the highest multiple R-squared value was this one that looked at the TOEFL reading score, the TOEFL speaking score, and the TOEFL writing score, as well as the year, which was the only categorical variable here. So it was interesting, you know, I basically eliminated all of these factors, like speaking was, listening was eliminated, number of attempts taking the test was eliminated, and the averages were actually eliminated, I think due to collinearity. So I end up with this, and an interesting conclusion is that this speaking factor is actually negative. So that it seemed that the lower students did on the speaking, the higher their SAT scores would be. And that I found that really odd.
Yeah, I don't know what to make sense of that. How do you make that's odd.
Yeah, and it is hard to the other things are a bit easier to rationalize, like the number of attempts, for example. You know, the more the student did it, the TOEFL, the more likely they would be on that curriculum and less time for the SAT related curriculum. So it seems like number of attempts of TOEFL would correlate with, you know, overall SAT performance negatively. But for this one, you know, I just think they probably spend less time doing translation, because actually, you know, translation could be a very effective part of the, you know, doing well on the SAT reading section and grammar section. And a lot of these students just probably translate the questions, but, you know, probably the translation might affect their ability to speak well.
Yeah, actually, now that I think about this, I didn't talk about this. I think it's covered in the textbook somewhere. Is Simpson's paradox? You could just be observing that, and that there's some other confounding variable that's causing that.
Well, one thing I did break up the classes again, and then I did try to identify if the most you know, important explanatory variable was somehow related to the class. So, like, for example, this class, last year's graduating class, their reading was a better predictor than even the average score. And you can see the speaking here is much, much lower. And then for the other class, it worked out that the writing was actually a better predictor of total SAT score. And again, the reading was above that, and the speaking was the lowest. So basically, you know, I'd like to be able to, you know, fill this data out over the years and just see if this relation persists. Thank you.
Yeah, thank you. I can't wait to read this in detail. Thank you very much. I'm going to send you a small note in the private chat for you to look at later. Let me get my... No, I need to make myself presenter. Oh, boy. Come on. Here we go. All right, and since it came up, I just did a quick... the Wikipedia article I think we'll do is just... oh, I'm sorry, Wikipedia. I'll donate later. For those who aren't familiar with Simpson's paradox, it's this situation where if you have a data set that looks like this is a fairly extreme canned example, but the point is the same. If I were to estimate a regression model with all of the variables, I would end up with the negative slope. But if I estimate a regression model or I include this grouping variable, then the slopes will end up actually being positive, right? And this shows up actually more often than you would think. And in fact, I think I have a fairly complicated project. A project I'm working on where I'm potentially estimate lots of models. I have these grouping variables. It's a simulation study looking at inter-rater reliability and with relation to intraclass correlations and where there are different designs. I'm interested in the context where you have multiple raters rating, and you're trying to evaluate inter-rater reliability. And the literature says use intraclass correlation. And through simulations, I'm writing a paper arguing that no one knows how to interpret intraclass correlations very well, and it's highly correlated. Like if you know any design, it's correlated with, or the R squareds, if you were to model ICC from percent rater agreement, it ends up being in the 90%, except in a couple of instances, if I try to just run a giant multiple regression where I take into account those models, the R squared diminishes, even though the average of all the individual models is really high. And me and a colleague are trying to figure this out, and best we can tell, we're probably hitting, we may have Simpson's paradox, but because it's so multidimensional, it's kind of really hard. Where you have just one variable or two variables in essence here, it's a little bit easier. Anyway, so check that out, Simpson's paradox, something you should be aware of that can occur. All right. So thank you, everybody. So I'm not going to present anything really terribly new tonight, but I just like to give you guys a little bit of a sense of what my background is or what my research interests are, at least from a statistical point of view. Like right now, I'm running a grant where I'm looking at formative assessments in college readiness more broadly, but from my dissertation work started, and a lot of the work while I was doing my dissertation, even since then, has been around quasi-experimental designs and in particular propensity score analysis. And that's kind of how I fell into this, and kind of how I fell into data science more broadly, because one of the big issues in propensity score analysis, or one of the things we want to do, is try to predict treatment from observed variables. We tend to call them observed covariates. So these are situations where we have an observational data set, and so people self-selected to be in the treatment. So we know that selection bias exists, but we want to adjust for that in some way. And the way we tend to do that is say, well, if we observe enough about these individuals, can we model or predict who's going to be in a treatment or not? And if we can do that accurately with sufficient fidelity, then what we can do is subdivide then those and say, well, we have some people who have high probabilities of being in the treatment that were in the treatment, of course, but then by some other random chance, we have some people who are highly likely to be in the treatment but weren't in the treatment. And then we're just going to compare those two together, right? We can do it as matched. We can match them 1-to-1, or we can do them through stratification where we create small groups, right? And so a lot of my effort is really revolving around trying to accurately predict this outcome. And my outcome of interest is treatment placement. And this dovetails really nicely in data science, because a lot of what data science is concerned with is just predicting things. And so I've looked at this in various different ways. Some interesting things as you guys go forward. I have a sort of small divergence in my discussion section of my dissertation, where one of the things I observed is that you should be aware of is as the ratio of true to false, right? So in my case, treatment control. In your case, it could just be however you dichotomize or operationalize your outcome. If you have true false, as the ratio of those increase, where you have one group that's overwhelming. In other words, you're trying to predict rare events with logistic regression, you're going to find that the range of the predicted values out of logistic regression is going to shrink. So if you have roughly 50-50, you'll see the fitted values are going to spread almost across the whole range between 0 and 1. But in my case, and I was looking at charter schools and traditional public schools in a situation where like 3% of my sample was in the treatment, 97 were in the control. And I use logistic regression, the models fit, I get, significant predictors, I can get accurate models. But if I look at the fitted values, I find that the range of values is like between 0 and 0.1 or something like that. Really, really small. And there's this shrinkage. And if you look at that, I address that vis-a-vis simulations, which is kind of how I like to at least initially explore any problems. Is like, can I simulate data and look at where I can control how things vary? Anyway, so propensity score analysis, actually, I have this condition. So this is kind of going back to chapter 1 stuff, right? And the way the textbook presents it, right? How do we get causality is we control something and we randomize somebody to treatment and control. And so the differences in the averages at the end is the treatment effect, right? And we can step back a little bit further. And so this little figure here that I created is based upon something called Rubin's causal model, which is what is a, I argue that what textbook argues is certainly the gold standard because it's what we can do, but that is actually technically a compromise to the true causal effect. A true causal effect, right? If we have some research subject, the real causal effect is if we can split the universe into two, and we want to take that single individual and expose them to condition A and condition B simultaneously, such that everything else in the world is exactly the same. The only thing different between these two universes is that we gave this individual condition A in universe A and condition B in universe B, and then the causal effect is the difference in the outcome after that at the same exact point in time, right? This is what Rubin calls, this is the actual causal effect. Now, one of his students, Holland, there's a paper from 86, kind of coined this as the fundamental problem of causality is that you could never observe this. And so when we think what we're doing in a randomized control design is I have a lot of individuals and I'm going to flip a coin and some of them are going to go to universe A and some of them are going to go to universe B. We can't actually between each individuals measure the difference, but we can, if we have a large enough sample, we get there, right? So if you can imagine that. Now, for quasi-experimental designs to work, what we're going to say is, well, we didn't even randomize this, but we know a lot about the mechanisms for how people would end up going down these two paths. And so if we subdivide that, we can then kind of do some comparisons. So that's basic propensity score analysis. So if you go, I have a GitHub. So if you go to JBriar PSA, there's a bunch of information. There's actually I have a whole Shiny app where I have some built-in data sets. And you can actually upload your own data set. And the way this works is you guys have most of the methods now to do this. And so here, this is a study that I did where I wanted to look at the impacts of tutoring services on students who chose to use tutoring, who didn't. And here's the whole set of variables in the data set. And I'm going to estimate propensity scores based upon their gender, ethnicity, military status, ESL, whether or not they're an English second language, education level, employment, right? These are all these variables. And over here on the side, I can say, these are going to be my covariates. My outcome of interest is course grade. This is my treatment variables defined there. And there's some other parameters that I'm not going to go into detail. And what I end up doing is running a logistic regression. All right, so here's my logistic regression summary. The fitted values for my logistic regressions are called propensity scores, and they're interpreted as the probability of being in the treatment. So here's my density, so you can look at the distributions. So we can see, I have, so this is the treatment as one would expect. The distribution for treatment students is going to be a little bit higher than those. But there's enough overlap here, so I can start slicing this in ways to either match or stratify people. And of course, there's a lot of different things you want to do. You want to check balance. So this is using 5 strata. And this red line is the effect of each covariate. So you could see gender is a significant predictor, or I'm sorry, is a significant confounder to the treatment effect. right? But after I do stratification, the effect of that is less than 0.1 is generally my threshold. I want the effect size to be pretty small, but overall, the balance is better as we go through. And then we can do things. I'm just going to go to stratification. So if I divide this into 5 equal grouping size, right? I have 5 strata, and then I can look at the treatment effect. And so this little plot here is on the x-axis here are control groups, here are treatment students, and this unit line. So if I had that any points that fall on it means there's no difference between the treatment and control. Each of these strata, each stratum is of individuals that are equivalent on as many of those covariates as we can do. And the fact that this green line, which is a 95% confidence interval, doesn't span zero, says that there's a significant effect, right? And so there's a lot of qualifications here, but that's a lot of what I'm doing. And I've done a couple of extensions to this. So if you find yourself needing to do this kind of work where you're making causal estimates from observational data, it's something you can reach out and I could do some helping, right? So this is sort of the general procedure. So my specific work, my dissertation work was I built an R package to do this with multi-level data where there's some kind of natural clustering. If you have 2 treatments in one control, right? So I wrote a package called TriMatch, which will do matching with 3 groups. So you essentially create matched triplets and run various types of variations of ANOVAs to look at the differences. And then also there's a bootstrapping package that if you want to bootstrap propensity score analyses, you can do that, which is a package that I kind of like quite a lot. So at the beginning, I also, wrote the Likert package and a few other things. So those are things that hopefully you can find use. Hopefully over this break, I'm going to release version 2 of the Likert package, so you can look out for that. But yeah, so that's sort of in a broad sense, or from a statistical point of view, what I'm doing. I'd like to point that out in case you find yourself needing to do some of this. Don't hesitate to reach out. So you're going to do the final exams. I'll give feedback and that and the projects coming as I get to grading the project over the weekend, and then early next week should be able to be grading those final exams. Just to reiterate, here's all my contact information. As the course goes down and the Slack channel kind of quiets down, you have my email, my GitHub repo, my blog. There's a link to my LinkedIn if you want to connect on LinkedIn. That's I accept it. I don't do a whole lot on LinkedIn, but I know for some of you, having those connections can be helpful. I am on Twitter, although I don't tweet as much as I like, but you can connect with me there. A few other little quick notes, administrative notes. So if you haven't, let's see here. So if you've gone to the GitHub repo, so if you go, there's a link at the top of the course website. So if you guys have probably been going to data606.net all semester. If you click that GitHub link, you end up here. So hopefully you're getting more comfortable with GitHub. Of course, you can clone or download it, clone or star it. This repo is not going to go anywhere, but I do encourage you, if you want to keep the materials, at minimum, download a zip file. Maybe after tonight, I'll make at least one more modification tonight for the slides for tonight's meetup. Then you have a complete copy of all the labs. The textbook is in there. All the slides are in there. So that might be a nice thing to have archived, so you have some reference materials going forward. Excuse me. Come early January, this website for this semester is going to move to this URL. So if you just want to view the website online, I'll just going to move it to fall2018.data606.net. And so if you want to get to it that way, you can do that, because data606.net in early January will be more or less blanked out, and I'll rebuild it for the spring semester. So I just want to make you aware of that. That's really all I had. This has been a fantastic semester. I've really enjoyed reading all of your work and working with everyone. It's been a great semester. And if you have any questions, I'll stick around for a few minutes and answer them. Otherwise, like I said, the final exam will become available in about 15 minutes if you care to look. Otherwise, you have plenty of time to get it done by Monday. Hope And otherwise, have a fantastic holiday, and I really appreciate it.
Thank you very much.
Yeah, my pleasure. All right. Have a great night. Have a great holiday. Great New Year. Oh my God, the last thing, I think I mentioned it last week. If anyone happens to be going to our studio, drop me an email. I'll be there. I'll be in Austin in January. I would love to get a coffee or a beer if or whatever your vice might be.
Professor Barry, this is
Yeah.
Eunice. Can I ask you like 2 quick questions?
Yeah, of course.
One is, sorry to bug you about this. Do you know if the answer key, and sorry if you already spoke to this, but will the answer keys to textbook problems be available at any point?
Oh my God, I didn't send that, did I? I am so sorry. Can you just drop
I
me
mean,
in?
it's not a huge, yeah.
Yeah, just
Email?
let me look here. So I have it here. Where did I put it? That completely slipped my mind. I don't know how that dropped off my radar this semester. Drop me an email and I'll send it to you.
Okay. Awesome.
Yeah, here it is.
Yeah, not a biggie.
I can. You know what kind of threw me off on this. This is just a small. I'm trying to feel like I'm making an excuse. I just got word that they're going to have a new edition of the textbook, and I actually agreed to be a reviewer of the textbook, which is fine. I'm happy to do that, but they're going to split chapter 1 into 2, and they're updating a bunch of data sets. So I was working through breaking it up, but I have the solution manuals. You just have to promise me not to share it, because I promised the book authors I wouldn't share it.
These are for the current version of our textbook, right?
Yeah, it's a current version of our textbook. Okay. But now that I know that there's a new edition coming out, it's going to be less valuable. But I had it. I wonder if it's in another. I did last semester. I sent it out, and I'm right now. You drop me an email, and I'll get it to you. It'll be in the top of my priority inbox, and I'll send you. I can send you them all, and if I find them broken up by chapter, I had that once, and I had to update it. Yeah. Okay. Otherwise, I'll send you the whole solution file, which is odds, not even the ones I didn't assign.
Okay, got it. Yeah, I don't mind waiting through. I just wanted, there were some questions that I was like, I would like to know what the correct answer is. So yeah, that'd be helpful just as I'm working through the final. The other one, and this is more of a just kind of a inquiring about your personal preference for the project. I tend to want to kind of hide a lot of the code in the output so that the final like report looks a little bit cleaner and you just see more like visualizations. Is that okay, or would you prefer to see the code all in the HTML output?
No. Actually, yeah, that's also another very good question. I don't. Yeah, make it pretty for yourself. And you can always just attach the RMD file.
Right. Okay.
I want, for the proposal, I wanted to see all the bits because I made comments for a few folks who had issues, and if I saw the R code, I could help them just fix that problem. But at this stage, I'm hide it.
Okay.
Yeah.
You're more interested in kind of like the thoughts behind it and like what was done and why and all that.
Yeah, exactly.
Like, okay, got it. Yep. All right, cool. Thank you. That's helpful.
No problem. I'm looking. Where did I put that? I'm gonna look in the. I had it all nicely organized at one point, and then they changed. New additions drive me nuts.
Sure. Yeah. All right, I will drop off to work on the project.
Yeah, I think almost everyone else is off.
Okay, thank you. Bye.
Yep, bye.
Professor, I have a quick question also about the final project.
Yep, go ahead.
So my project, I typically provide a HTML rendered link apart from the HTML link, because on GitHub, it's if you just click on the link to the HTML file, you don't get the rendered version. But the final project, because the file was heavy. I don't think it opens. So I think you have to sort of download the HTML file and open it. I don't know if there's a way around that or
That's
if it's
fine.
okay.
Did you
So
put it in a zip file before you uploaded it on Blackboard? Or
No, I guess I should do that.
that might be. Are you having? Were you able to submit something to Blackboard?
I was able to submit something to Blackboard. It's just a link to the final project on which I uploaded to GitHub.
Oh, and did you use the HTML preview feature in GitHub?
Correct. I use it says GitHub user content. htmlpreview.github.io, and it typically it's worked for every other thing that I've uploaded,
but not this one.
not this one.
Can you update? If you just link to the raw HTML, then I'll just save it and load it locally. That's fine too. Yeah, that'll be fine. If it's already on GitHub, I think you can just add a. You know what? The link will be in the HTML preview. Since you alerted it to me, I'll when it doesn't work, I'll remember when I see that HTML preview. HTML, yeah, it's htmlpreview.github.io or something.
Right. So it's
Actually,
basically.
Oh no, that's how I do it on the course website. Where am I? I think that's how. Is that what I do? Oh no, I don't. That's right. I used to do it that way.
Okay. Yeah. So what's up on GitHub is basically the data file, the HTML knitted version of the RMD file and the RMD file.
Yeah, that should be fine. I should be okay.
Okay.
With that. Josh is asking,
you.
I'm not presenting at our studio conference. I'm just going to learn and meet some friends. Oh, no. I'm a terrible Twitter person. I don't tweet a lot. I consume a lot. All right. I think we'll call it a night. Have a great night, everyone. Good holiday. Thanks.